Hello everyone, welcome back. So in this video, we are going to understand the problem number 1914 from the Leetcode in the daily contest. The question saying that we have to cylindrically rotating a grid. Okay, so we'll understand how the question saying to implement, right, the problem. Very first, read the question. Question saying that you have given a matrix m cross n, as you can see here. It is integer grid matrix we have given, and both are like m and n, both we have given is even integers. Okay, and integer k we also have given. The matrix is composed of several layers which shown in the below in different colors, its own color. Let's suppose the very first layer it is talking about is the blue one, right, the outer layers. Then we have the inner layer is in the yellow color. Okay, so now after that, what it is saying that cyclic rotation of matrix is done by cylindrically rotating each layer in the matrix. Okay, so how will you do the cylindrical rotation? That is what the question is saying. Now it is saying that to cylindrically rotate a layer once, each element in the layer will take place of adjacent element in the counterclockwise direction. For example, the things what we have given is it start from here, right? Means it start from one, the left corner first, left top corner we can say that, and it keep going down, right? And then it goes to right, then it goes to up, and then it goes to left again. Means it is kind of counterclockwise direction, right? So we do before the rotation, this is the before the rotation. Once the rotation is done, because k we have unique equal to 1, we will do one rotation. After the one rotation, you will get the element like this. Okay, then it is saying that once you return the matrix applying k cylindrical operations to it, you have to put back the code, the value to add that locations. For example, let's suppose we'll understand this one, right? 40 30 20 like this we have, right? So we know that one rotation means 40 will come down to near 30, right? So you can say, and this 40 this 30 will go to 20, so you can see here. Similarly, this 20 will go to the 10, you can see this 10 will go to the 10, the first one. Like this one rotation will happen, right? So before the rotation and after one rotation you can see, and once do the rotations, you have to give that you have to store that value at that positions only, right? And that will be our answer. This is what the question is saying, guys. I hope till now you have understand. So I'll show you a very elegant solution, and it's an interesting part of the thing, right? So let's tell you how to implement. Okay, first I'll show you the code. Why? Because this will give you the intuition to understand the problem itself. Okay, so I'll zooming out, it will help you to understand. Okay, so we are at a simple zoom out position. Okay, so you can understand the very first, this interesting part is that this code uses a coordinate mapping technique. Okay, so instead of we extract and rotate and reinsert those separately, right? Let's deeply understand what is happening here. Okay, so the main idea is for every layer we will store all coordinates row and column, right? Let me give you a second. So basically what I'm trying to say that for every layer, right, that we have seen that give me 1 second. If we will write the matrix like this, okay, so this was the outer layer, if you remember, right? The very first layer was outer layer. So this outer layer, and then we got the inner layer like this, right? And more grid values were there, right? So for every layer, right, what we need to do, we have to store all the coordinates. So let's suppose coordinate is what is the position is there, what is this position is there, what is this position are there, right? These positions. So we will store all coordinates, okay, like the row and the column. Simple. Then once, means I'm talking about for every layer, right? Then we will store all values. Okay, what is the value at this position? Let's suppose 1 9 16, like that we have some elements we have, right? Once we will store the coordinates and the values, then what we should do, we should compute where each value should come after the rotation. Okay, and once it is done, we'll put values back directly. Understand? Means for each layer that we have seen, right, or we can say we'll see in the grid, right? The very first we will store all the coordinates, then we'll store all the values, then we'll compute where each value should come after the rotation, and we'll put values back directly. So let's understand. The very first thing is that for each layer, so we see that layer will start from 0 and we'll go to the nth layer, right, like that. So now we'll say, okay, how we'll understand that how many layers we have. So you can compute like this. So if you have given m and n, right, so you just use math.mean m by 2 n by 2, you will get the level counts. Okay, so when you will get the level counts, you will start for each layer, right, that we have understand. So now we'll start these 4 steps, right? The very first thing that we need to find row and column, because we have to store the coordinates, right? Then we have to store the value, so we'll use these 3 things to store the value, coordinates and value. We will use these 3 lists. Okay, so each elements row index and column index and values, these 3 things we have to store. So how we'll do that? Let's suppose that we start from the layer 0, means the very first layer. So what I will do is, okay, we are talking about this layer, the outer layer. Let's suppose when I equal to 0. So what you will do, we'll start I equal to layer, and you will say, okay, I should be less than m minus layer minus 1. So this will give you the value, right, for the left layers, you can say, because we need that, right? So we'll store that. The very first we'll start from the top left corner, right, because we know that for the counterclockwise what you need to do, we'll start from the top left corner. Basically we want to start from here, right? Then what we will go, we'll go down, right? Then we'll go right, then we'll go up, and then we'll go left, like this. The counterclockwise we'll say. Okay, so left will go, will down will go, right will go, and up will go. So like this we will go. Okay, then each time we'll store the coordinates and their value, coordinates and their value, coordinates and their value, coordinates and their value. Means like this we will store in each positions, right? Now it comes to the total value, right? So let's suppose that how we are thinking here, right? So let me clean here so you can understand. So we are at here, right? We have stored all the things. Okay, let's suppose we'll take a matrix 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16, because we need at least 2 layer, guys. Okay, so think of this is a grid we have given. Okay, so after the outer grid, this is our inner grid, right? Just I am not putting all the lines, right? So outer layer traversal, how will it become, right? We'll start from 1, then we'll go to the 5, then 9, then 13, then we'll go to the 14, then 15, then 16, after 16 12, then 8, then 4, then 3, and then 2. Like this we will do the rotation as we have understood, right? Basically we are going, how we are going down, then we are going right, then we are going up, and then we are going left. Like this is our rotation becomes, means it is called counter clockwise, right? Counterclockwise traversal, correct, guys? So when we go for the left wall, left, suppose this one, right, means we need a layer, right, that will start from where, layer here, then we'll go to the m minus layer minus 1, right? So for, let's suppose layer 0, right? What are the coordinates are there? These are the coordinates. These are the coordinates. Means we'll say coordinates are 0 0, then we'll say is 1 0, then 2 0. Like that we will say that. Okay. So we'll take 1 5 9. 1 5 9 will take, because this will go to the next level. Okay. So you leave this one. This will not go inside. Okay. So 1 1 5 and 9 we are talking about. The very first value will go inside this one. Okay. Then we'll come for the bottom one, this part. Okay. So I think you will not you will not take this 15. Okay. 16. You will get these values. Let me remove. It is 13. Okay. Yeah. So like this will happen. Okay. Coming back to here, let me clean this part so we'll understand. You know the how the clockwise direction will work, right, guys? Okay. Now think that once this part is done, then we'll go to the bottom section. This section we are talking about, right? So here we will use the layer, this one, right? For the down one, j will start from layer, j will go to the n minus layer minus 1, right? It means what are the coordinates will be there? This is the first value we'll get from there, right? Means we'll say 3 0, 3 1 and 3 2. Means basically we want from here is 13, 14 and 15, correct? Then this is also done. Now we'll go with the this part, the right part. Means we are talking about these three elements, right? So similarly the coordinate will be 3 3 2 3 1 3, right? Like this, and it will give you the element 16, 12 and 8. Well, this will give you the value. Okay. Now we'll talk about this one. How many elements will you get from here? Is this part, correct? So we know that the top wall will give the elements 0 3, 0 2 and 0 1, right? 0 3, 0 2, 0 1. These are the coordinates we will get, and the element we will get is 4, 3 and 2. So once you will extract, right, and you will give the final extracted rings, right, you will get the values, right? So if we'll include all these values, so very first we'll get 1 5 9, then we'll get is 13 14 15 16 12 8 and 4 3 2. So let me read it again. Basically we will get 1 5 9, then we in the next round we'll got what, 13 14 15, then we got is 16 12 8 and 4 3 2. Like this we will get a values, right? Now we need a so this is in online, guys. Okay, don't think that this is in different line. This is all in the online. Now once you do that, then you need the rotation logic. Okay, so this is the most important line. Basically, how will you find the rotation logic? So if you see here, we are using the rotation logic here at this position. So why? Because you suppose that we have some element. Let me show you how. So let's suppose that the values we have is 1 5 9 and 13. We are talking about the very first elements, and k we have is 1. So these are the values we have, and k is 1 we have. So after the clockwise, let's suppose after counterclockwise, say, okay, counterclockwise, after counterclockwise rotation, what should be the element? It should be basically, it will get changed, right? It will become, the very first will come 5 9 13 and 1, because there is one k rotations are there. So these are the elements will become, correct? So for position I equal to 0, right? What we need? We need 5, correct? Which came from where? The index 1. We'll say index, which came from index 1, right? But instead of pushing forward, the solution pulls from old index, right? So that old index will get from where? idx equal to I plus total minus kk mod total. Okay, so I is the current position which takes from the shifted old position, right? And like that, if you will find, so you'll say okay, the new array, let's suppose, is 0, which we can get from the old 1. Like this you will get, let's suppose for 1 will go, 2 will go, for 3 will go, let's suppose for 2 will go is 3, 3 will get from 0. Like that we will keep adding all those values from each index of the new and old, right? So this becomes, basically you will find the old index. How will you find the old index? Very simple. You will say I plus k and you will take the total, and this way you will find the old index, right? So it depends on traversal direction also. So you will say okay, I plus total minus k, and you will take the mod total, right? So this will give you the traversal direction. Based on the traversal direction you can use, or you can use the old index also. Both are valid depending on the ordering. Okay, so either you will use this one, I plus k mod total, or I plus total minus kk, and this one. It depends on the traversal direction, and it is the equivalent formula that either you can use it. Okay, so coming back to here, you will use this formula, right? And you just need to do what? You will find the grid at I and j you will get, right? And what we have, that value will store, that you will store back it to here. Okay, because you calculated the value, and finally once you will store the value back, you will return the grid. So I hope you understand this problem, why this solution is nice, because it's very interview friendly question, and solution is also very good, very perfect solution is this, right? Because there is no duplicate coordinates, so they are very clean rotation math problem we have, and coordinates separates from the value, and it is easy for debug also, guys. So basically if we'll talk about the time complexity, guys, right, what it will give, it will give you O of m cross n, right? For every cell we process here, right, for every cells, and so it is taking actually O of the perimeter, right? And that is the for the space. Okay, so that's all in this video, guys. In case if you are struggling with anything, let me know in the comment section, and please like, subscribe this channel, and keep supporting ExpertFunda. Thank you so much.